dear students, welcome to a new lecture. Uh, we will continue our lecture from the previous problem we have solved. Mr. Bell, do you know why Mr. Bruce Wayne is absent? Why he is absent today?
Teacher, I'm not absent.
Okay, got it. I found you. Good. Okay, let's continue your lecture. But before starting the lecture, I want to ask you that do you have any question in the previous lecture? Dear students, do you have any question, any misunderstanding in the previous lecture? Mr. Jack, Mr. Sean, Bruce Wayne, Bill, Queen, all of you, do you have any question? In the previous lecture, I have solved a problem. If you remember, we have studied a numerical. We have studied this numerical in the previous lecture. Do you have any question, any one of you? Did you study it? Did you solve this numerical as a homework? I have given you this homework. Bruce Wayne, did you solve it?
Not yet.
Mr. Bell, did you solve this numerical at home?
Pardon.
Did you solve this numerical at home? This was your homework. Only one numerical. I have given you this numerical as a homework.
Yes, I know.
So, did you solve it? Mr. Charlie, Miss Granda, Miss Serial, any one of you? Did you solve this numerical? Miss Granda, please turn on your mic so that I can hear you. What you're talking about?
I wanted to know when will we how to say give you this homework.
Did you solve it? Just tell me, did you solve it or not? Did you solve this numerical at home or not? Yes or no? If yes, then send me the picture of your homework and widget group so that I can check your homework that did you solve it correctly, or if you did any mistake, then I will discuss that how to override on that type of mistake. If any one of you has solved, then obviously you will feel some difficulties in such kind of numerical. No one have worked on it. Very good. Quite lazy students. Your senior batch, Mr. Allen, if you know him, he is the most active student and the senior batch. He always do homeworks, he always do. So I'm just nominating his name because get inspired from him. Do work on the time. Don't be late. Okay. I don't want to repeat that homework again. I will not repeat this numerical again until you work at home. First, solve it. Solve this numerical. Solve this numerical at home. Understand? Solve this numerical at home Then discuss with me that did you understand or not. Okay, if you have any problem, please ask me. I am available. From here, I will continue my lecture from the next topic. It is most important related to the design of the next course that you will study the 4-story building design, and also in this course the study of single-story building design. So right now, these are the 3 major design philosophies. These are the 3 major design philosophies. Okay, we will study all these philosophies one by one. A design, what is basically a design philosophy? Design philosophy is a set of assumptions and procedures. What we do, this is basically a set of assumptions and procedures. Procedures of what? Designing procedures. Assumptions of what? We assume some loads, we assume some difficulties, some different parameters should be assumed in these design philosophies, and then which are used to meet the conditions of serviceability, safety, economy, and functionality of the structure. All these are the important parameters of structure. That structure should be serviceable, structure should be safe, structure should be economical, and structure should be functionable throughout its life. Well, several design philosophies have been introduced from different parts of the world. Some of design philosophies that has been used by engineers, such are, number 1, can you see these colors? This is the first one in red color, second is in blue color, and third one is in brown color. The first one is working stress method, and the short form of this philosophy is called WSM. We also name it as allowable stress design, and the short name is ASD. The first one is called working stress method or allowable stress method. Second one is ultimate load method, and the third one is limit state method. Understand? We will study all these philosophies, all these 3 philosophies one by one. But before studying them, let's talk about their historical background. This first one, can you see these? I have marked them as a color with different colors. The one, number 1 is in red color, so its historical background is from here to here. The second one is in blue color, so its historical background from here to here. And third one, its historical background is from here to here. Tom, please turn off your mic. Okay. What is the historical background of these design philosophies? The first one is called as WSM or working stress method, or we also called it allowable stress method. The earliest one is working stress method. This is the oldest one philosophy, that is name is working stress method. Understand? The earliest one is working stress method, which was introduced in 20th century. This is based on linear elastic theory. It is based on what? It is based on linear elastic theory. I will discuss this linear elastic theory on the next slide. There, what is the meaning of linear elastic theory? This method was used in Indian standard 456 till revision of also the Indian standard. This is the oldest revision and this is the newest one. And the second one, ultimate load method. And the ultimate load method in 1950s, in the year 1950, ultimate load method was introduced, which is based on the ultimate load. This philosophy is, this one, working stress method is based on linear elastic theory. And ultimate load method, ultimate ULM, ultimate load method is based on ultimate load. I will also discuss this on the next slide. What is the meaning of ultimate load? Which can be carried out by material. Its acceptance can be seen in ACI code. This philosophy is used in ACI code, American Concrete Institute code in 1956, and British codes in 1957, and Indian codes in 1964. Okay, and the most recently, that is limit state method. This is the new philosophy, and still your design of next semester will be based on this philosophy, this last one, this brown in color. The most recently accepted code of practice is based on limit state method. This is the most important philosophy. This is used in Indian Standard Code from revision from here to here, and British Code CP 110 in 1973. Also British Standard Code in 1997, and American Concrete Institute Code. The number of the code is mentioned here, and now American Concrete Institute Code. This is the revision of ACI code. So this is basically just the historical background of these philosophies. This was the WSM, the working stress method. Number one philosophy is introduced in 20th century, and it is based on linear elastic theory. Okay, and ULM, ultimate load method, is introduced in 1950s, and it is based on ultimate load. And limit state method is the new one, and this is based on what? This is based on limitations. And what are those limitations? We will study these things in the next slides. Now, the number one that is called is working stress method or allowable stress method. The number one is working stress method or allowable stress method. Let's study it. Working stress method is used for design of reinforced concrete structure, steel structure, and timber structures. Timber is a kind of wood. So concrete structure, steel structure, and wood structures, all these structures can be designed on the method that is called as working stress method. The main assumption of working stress method is that the behavior of structural material is restricted with linear elastic region. The behavior of the structure is restricted in the linear elastic region. Do you know the stress strain curve of steel? Can you draw stress strain curve of steel? Any one of you? Mr. Charlie, can you draw the stress strain curve of steel?
Sorry, I don't understand.
Bruce Van, do you know how to draw the stress strain curve of steel?
How do you draw what?
Stress strain curve. Okay, let me show you. Talking about, if you are not understanding my words. Stress strain curve of steel. Any one of you, can you draw? Mr. Bell. Okay, Okay, Miss Grenda, do you know? Miss Grenda also don't know. Kuzma, Noctis, Mr. Joe, the monitor of this class. Mr. Forio, Peter, yes, who speak? Yes, please tell me. Mr. Forio,
I don't know how to describe in English.
just I am talking about the sketch, the diagram of stress strain curve of steel. If you can draw, then you can show us. Okay, let me tell you how it is drawn. I have already added in your lecture. Let me show you. This is basically the stress strain curve of steel. On this side, this is stress, and on this side, this is strain. This is basically the stress strain curve of steel. Can you see this picture? This is basically the stress strain curve of steel. Okay. What does linear elastic region? What does linear elastic region means? Linear elastic region is basically, you can see the line from point 1 to point 2. This is basically the linear elastic region of steel. If you apply load on steel, and when you remove the load, it attains its own position, its original position, its original shape, then we can see or we can say that the proportional the steel is in proportional limit, and it is the elastic region of steel. From 2 to 3, it is the yielding strength, yielding portion. From here to here, you can see this is the yielding portions. From 2 to 3 point, this third point is the yielding strength. Yielding strength means that steel, when you remove the load, you have applied a load on a steel, and when you want to remove the load, after removing of load, the steel will not attain its original position. It will not come back to its original position in original shape. Elongation will be appear. And the fourth point is called as the ultimate tensile strength. This is the ultimate load. And the fifth point is fracture. You are applying a load on a steel. For example, you are applying a load on a steel beam or a RCC beam, for example. It will take the load at this point from here to here. It will be a proportional limit of the steel beam. After that, the steel will have a yielding strength. After this yielding strength, the third point, the steel will not come to its original position. This is the bending point of steel. And at the fourth point, the fourth stage, that is ultimate tensile strength. This is the maximum load that steel can take. This is the maximum load that steel or the member can take. And after that, the load will be reduced. The load will be reduced. When the load reduction appears, the member will be failed. The member will collapse. The member will crack. The member will demolish. All these are different words for the damage. Well, as I have told you that the main assumption of working stress method is the behavior of structural materials is restricted within linear elastic region. This is the linear elastic region. This code is deal with only linear elastic region. If your load increase from 2 to 3, then you cannot use this method. Okay, and the safety of it is ensured by restricted the stresses coming on the members by working loads. Thus, allowable stress will come in the linear portion, that is also called as initial phase of the stress strain curve. As I have told you, this is basically why we call it initial phase, because this is the starting point from 1 to 2. This is the initial point, this is the initial phase of the stress strain curve. Thus, a factor of safety was introduced to the design. What does factor of safety means? Factor of safety is the ratio of strength of material to the permissible stresses. Okay, it is the ratio of strength of material to the permissible stresses, that is called as factor of safety. This is WSM have some drawbacks. What are those drawbacks? Let's read them. It cannot account for the loads having counteracting effect. Those loads that have counteracting effect means the load can apply again. That load, this method is not suitable for that type of load. The example of those loads is dead load and wind load. Okay, the above will lead to non-conservative design. If you still use WSM method, then your design will be a non-conservative design for counteracting effects of loads. Working stress method will lead to large factor of safety. If you still use working stress method for counter-affecting loads, then it will have large factor of safety and oversized sections. Mean column size will be so bigger if you design by this method. Beam size will be so bigger, footing size, and all structure member sizes will be so bigger. It will have oversized sections. If the member size is oversized, if the member size is over the limit, then we can also call it that it is against the economy. The economy of the structure will be out of the limit. WSM is still, working stress method is still being using in special structures. We are still using in this century and 21st century, we are still using WSM method. And what are those structures of which still we are using WSM method? The structure name is water tank, chimneys, where we are using this method, and usually in India and sometimes even in Pakistan we still use this method. Well, elastic regions holds good and serviceability, but usually in Pakistan we use limit state method, LSM, the last one, limit state method. When elastic regions hold good and serviceability checks such as crack width, deflection, etc. This WSM method is applicable over there. Okay. Do you have any question in this WSM method? Rusman, do you have any question?
No, I don't have any question.
Dear students, please, if you are not understanding any part of the lecture, any slide, please ask me so that I can explain again with different words, maybe you understand. Well, the second method, that is called as limit state method, or the second method that is called is ultimate load method. That ultimate load method is explained here. Let's talk about ultimate load method stepwise. This is also known as load factor method. We use the second name for this method, that is load factor method, and also ultimate strength method or ultimate load method. Okay, and this we make a non-linear region of stress strain curve of steel and concrete. And this method we are dealing with the structure and non-linear region. What is the non-linear region? Means usually we are dealing with the structure from 2 point to 4th point. This method, this ultimate load method, is designed for the structure and non-linear region. And non-linear region, this is non-linear region from 2 to 4. This is the non-linear region of the curve. The safety is ensured by introducing load factor. We are taking the load factor, and it is ensured by the load factor. The safety of the structure is ensured by the load factor. What are those load factors? If you remember, the load factor which I have told you, these are basically load factors. The safety is ensured, and ultimate load method is ensured by these factors. If you remember, these are the factors of safety. In this case, we are taking 20% extra dead load, and in this case, we are taking 60% extra dead load. Okay. So, because of these taking extra dead loads, we are ensuring the safety of the structure. But in such case, for example, you have designed your building for ultimate load method. For example, the ultimate load limit of that structure is, for example, 50 psi. And in such case, in different events, for example, that structure load increase from 50 to 60 psi. In any case, then what will happen? Your structure will fail, because you have designed your structure for ultimate load method. If your load increase from 4th point, then what will happen? Structure will fail. That's why in this world right now, in this era, we are not using this method. Why we are not using this method? Because this method have also a limitation. Because if our load is increased from ultimate load, then what will happen? Structure will fail. So that's why we are not using it. But the load factor is basically the ratio of ultimate strength to the service loads. The ULM makes its ultimate load method makes it possible to consider the effects of different loads acting simultaneously. This method makes it possible that all different types of loads act together. Like you can see over here, there are the different types of load. This is ultimate load. U means ultimate load. There are different types of loads acting together in a structure. The dead load and live load will be added together, and this total value will be a ultimate load. Okay. ULM makes it possible to consider the effects of different loads acting simultaneously. These different loads act simultaneously, as I have shown you on the factored load combination slide. These loads act simultaneously, which was not happening in the previous method. That was working stress method, thus solving the shortcomings of working stress method. This was not possible in WSM method, and it was a shortcoming of WSM method. So ULM introduced and make it possible that the effects of different loads acting simultaneously can be considered together and simultaneously, thus solving the shortcomings of WSM. Now WSM is not being used, while the third and the most important method, that is called as limit state method, and you will also solve your structure on this method. What does this philosophy means? This philosophy is an advanced over traditional design philosophies. This philosophy is advanced over traditional design philosophy. Why it is advanced? Because it considers safety and it at the ultimate load, and it also considers serviceability at working. Understand? Sort of extension of WSM and ULM. And WSM we were only considering safety, and in ULM we were only considering for the working load. But right now we in this philosophy we are considering both together, safety and serviceability. Safety on an ultimate load, that is the shortcoming of the best part of ULM, and serviceability on working load, that is the best part of WSM. But we have combined them together in limit state method. Now limit state method is dealing with safety and serviceability. Safety on ultimate load and serviceability on working load. Dear students, the call is going to be disconnected because the first section of the class is completed. 40 minutes are ended now. Please join the meeting again within few seconds. If you have any question in the meantime, please ask me. Any one of you, do you have any question, any misunderstanding? Any one of you? Mr. Bell, Charlie, Jake, Noctis, Sean, Bruce Wayne. Any one of you, do you have any question? Mr. Bruce Wayne, do you have any question?
No, I don't have a question.
Are you understanding this topic?
Basically, yeah. It's about the walking straight.
Design methods. We are talking about, we are discussing only the design methods. Okay, let's continue. The third one, the most important method, that is also, let me repeat again, the most important method, that is limit state method. WSM was designed for the method. WSM was only for serviceability or functionality of the structure, and ultimate load method was only for safety of the structure. But limit state method is the one, this is the design philosophy which is advanced over WSM and ULM design philosophies. It considers safety and serviceability together. Safety on ultimate load and serviceability on working load. Limit state is the state of impending failure, beyond which a structure ceases to perform its intended function satisfactorily in terms of either safety or serviceability. There are two types of limit states. In this method, there will be two types of limits. The first is called ultimate limit state, which is considering the strength, overturning, fatigue, and sliding, etc. And serviceability limit state considers crack wet, deflection, vibration, etc. Understand? Ultimate load method or limit state method is dealing with two types of limits. And ultimate limit state, it considers the strength, the safety part. Can you see this safety part? This safety part considers for dealing with ultimate limit state. It considers strength, overturning, fatigue, and sliding. Okay, and serviceability limit state is dealing with serviceability limit state. It considers crack wet, deflection, vibration, etc. Okay. So, ultimate limit method is uses for multi safety factors for required safety and serviceability at limit load and working load. Safety on ultimate load and serviceability on working load. Okay, so I am repeating it again and again because it is most important. Please memorize it. That ultimate load method is dealing with two types of factors, that is safety and serviceability. Safety on ultimate load and serviceability on working load respectively, by considering all limit states. There are these are called partial safety factors. Let us study partial safety factors, and we have already studied these factors. And the slide which I am going to show you again, let me show you. This is basically the slide, the factor load combination and also the service load combination will deal with these two types of limitations. So this is because of the code ACI, American Concrete Institute code. Okay, and those safety factors, these one are for because of Indian Standard Code. Understand? So that's why these factors are little different. Different codes use different factors. For limit state, ultimate load will be used 1.5 as a safety factor for dead load and live load. Similarly, ultimate load safety factor will also consider 1.5 for dead load and earthquake load, and dead load for earthquake load. If you are considering it together, you can use this factor. If you are considering it one by one, then you can use this factor. Both are okay. Ultimate load, if you are considering all these things together, dead load, live load, and earthquake load, dead load, live load, and earthquake load. So we have to use 1.2. So this is quite same as the ACI code. The load factor 1.2 is considered for the combination of three, because the probability of three loads reaching its peak together are less. That's why we are using 1.2 instead of 1.5. Similarly, serviceability limit state, we are using these factors. The load factor is taking 0.8 in the third case. Is the probability of wind load.
Oh, yeah.
Don't talk. Who is talking?
Okay.
load factor 0.8, and the third case is the probability of wind load or earthquake load acting with peak of live load is less. That's why for all cases the safety factor is taken as 1, and we consider the serviceability of the structure here. Where dead load, DL is for dead load, LL is for live load, and QL is for earthquake load or wind load. Okay, and most important thing which I want to discuss for you, Mr. Bell, Bruce Wayne, please understand, try to understand. These are the video lectures of different chapters. For example, PCSD, Principle of Concrete Structure Design, Lecture 1, Chapter number 1. If you want to, if you forgot what I have said in different lectures, you can watch it. I have recorded my lectures. Just click on it and watch the lecture. Similarly, PCSD Lecture 2, Chapter number 2. And Lecture 3 we have studied, and Lecture 3 we have studied Chapter 3, and Lecture 4 we have still studied Chapter 3. And right now we are studying Lecture number 5, and we have finished our Chapter number 3, and we are moving towards new chapter, that is Chapter number 4. Let's move towards Chapter number 4. But before going towards Chapter number 4, do you have any question and complete Chapter number 3?
Teacher, you send us the PPT you sent us before didn't have this link.
I will send this again because I have added the URLs right now before 20 or 30 minutes. Okay, I will send this PPT again in your WeChat group so that you can use these URL. But the only one thing that is most important, that you have to use
VPN, right?
There are so many free VPNs available in China. I have
not everyone has.
I spent
Not everyone will
years
have
in China,
to
so I know. I am a foreigner. I spent 2 years in China, and I was using different free VPNs. Even if you want to see my mobile, can you see over here? These are the different VPNs which I have installed in my cell phone. Let me show you. I have sent the picture of free VPNs in your WeChat group so that you can know that these all are free VPNs. I am using them. Okay, let's move towards chapter number 4. Do you have any question, dear students? Any one of you? No question? Okay. Let's move towards chapter number 4, the quite important chapter, and before starting this chapter, I want to announce your project over here. Listen, dear students. This is your project and you have to submit this project. This is a group task, okay? Do you all know what is your group number? I have sent the group list and your WeChat group. So you have to use your own group number. You must know about your group members. What is your project? This is a group task. You have to submit it on uh, uh, you must have to submit this on 25th December to 2020. Okay, it is a typical one-story office building. It contains 3 spans in this direction and 3 spans in this direction. Okay, the size of the building, that is 60 feet by 60 feet. You have to use 60 by 60. So each span from this column to this column, from this column to this column, this span is 20 feet, 20 feet, 20 feet, 20, 20, 20. 3 span building in both the directions. FC prime, the compressive strength you need to use, that must be 3000 psi. Fy is the yielding strength of steel, that is must be 60,000 psi. Dead load will be used as 60 psi, 60 pounds per square feet, plus A. What does this A means? A is your group number divided by 10. Okay, Bruce Wayne, what is your group number?
I forget it. I need to check the letter.
Okay, for
Letter you send
example,
us.
your group number is 4. Then you need to use group 4 over here divided by 10 and add it in the place of A. Okay. Similarly, for live load value is 50 psf plus A. What does this A means? Group number divided by 10. Assume rigid floors and masses lumped at floor levels only. Clear? Okay, dear students, let's start your chapter number 4. The name of the chapter number 4 is Bent Component Direct Bearing Capacity Calculation. We will study in this chapter bent component, means the beam design. Understand experimental research and analysis. These are the contents of chapter number 4. Understand experimental research and analysis, bent component direct bearing capacity calculation method, bearing capacity of single steel rectangle cross section and bearing capacity of double steel cross section, double steel rectangle cross section, and trapezoidal cross section bearing capacity. Okay, these are the different topics which we will study in this chapter. Let's start chapter number 4. The first topic of chapter number 4, that is supports. Do you know how many supports we are using in our structures? studied these supports? Bruce Wayne, did you study these supports?
What means support?
Support of any beam. For example, this is a beam. Can you see that? This is a beam. This is basically a support. These are supports.
Oh, I know it. We learned it from our Chinese class.
In which course you have studied it? Structural design.
Many, like how to say, I don't know. In Chinese we call it 材料力学. It's about the force in material.
It's okay. This course is basically you have studied. It may be studied in strength design method or structure analysis course. All these are different courses which are the prerequisite of this course. So you have studied. So I am just repeating it for your better understanding. There are 4 supports. Listen, there are 4 supports. The one is called roller, simple, hinge, and fixed. For roller support, these are the examples of roller support. This is also a roller support, and roller support. We are using these different types of roller support for different types of structure. This is a simple hinge support. Can you see that? This is a support over here. This is support. This support is called as simple support, and this support is called as hinge support. Okay, simple support and hinge support. This support is called as fixed support. Can you please tell me which support is it? Mr. Bell, can you please tell me which support is this one? The last one, which I have encircled. What's the name of this support?
Sorry, I don't know.
Why you don't know? As I am telling you, this is roller support. These are the different roller supports. Okay. This is simple support. See the shape of simple support. This is hinge support. Okay. This is fixed support. You have studied it in the previous courses. Then what is this support? Guess the support type. What type of this?
Fixed support.
Who replied? Mr. Pario, did you told me?
Yeah, fixed support.
Okay, this is the fixed support. 110% you are correct. So this is basically, Mr. Bell, this is a fixed support. Okay. Okay. So support their attachment and reactions. If support is roller, then what type of reaction will be generated? What type of force will be generated? That is only vertical force, that is F. For hinge support, it can resist 2 type of forces, an Fx and an Fy direction. There will be 2 forces, Fx and Fy. And fixed support can resist 3 reaction forces, Fx, Fy and movement. Okay, these are the reaction forces which can be resisted by different types of supports. Roller support can resist only vertical reaction. Pin or hinge support can resist horizontal and vertical force. Fixed support can resist three types of reaction and forces: Fx, Fy, and moment. Okay. So, free body diagram, FBD means free body diagram. FBD means F for free, B for body, and D for diagram. So, free body diagram of different supports with reactions. Roller support and its reaction, hinge support and its reactions, fixed support and its resistive reactions, and simple fractional surface will have only vertical force. Roller support will be drawn by these lines, hinge support can be drawn in this way, and fixed support can be drawn in this way, and free body diagram. Because the body is not available in this diagram, body is not available in this diagram, and body is not available in this diagram. So let's start. The first topic here is beam. Do you know what does beam mean? Beam is basically a structural member. It's a longitudinal structural member that primarily resists loads applied laterally to the beam axis. Structure, it is basically a structural load. Structural element, it is basically a structural element which is designed for structural load that primarily resists loads applied laterally. It resists those loads which are applied laterally. Laterally loads means that load which is applied on its complete length. For example, in this direction, these arrows shows the downward. This is basically the application of load. If you apply the load in this direction, the load must be applied in this complete beam from one edge to another edge of the beam. Okay, that load will be called as lateral load. Its made of deflection is primarily by bending. Can you see that beam can deflect, can be bent in this direction? Beam failure mode is bending. Okay, the loads applied to the beam results reaction forces. When we apply forces on the beam, it will result in reaction forces on the support. It will result reaction forces. Reaction force over here, reaction force over here. If it is a roller support, so it will have only one reaction. Hinge support will have two reactions, one in this direction and one in this direction. Okay. The total effect of all forces acting on a beam is produce shear force. When we are taking the total effect of this beam, these two reaction forces, this applied load and this reaction forces, when we combine them together, it is used for drawing or the diagram of shear force. It produces shear forces and bending moment. It will produce what? It will produce shear forces and bending moment within the beam. That is turn induced internal stresses, strain and deflection of the beam, because of which internal stresses, strains and deflections of the beam can be induced. Beams are characterized by their manner of support, profile, shape of cross-section, length and their material. These are the different characteristics of the beam. There are different types of beams available. This A is called, this shape beam is called as cantilever beam because it will have only one fixed support on one end. The other end is free. There is no support on this edge. So that's why it is called as cantilever beam. If the beam will have simple supports on both the edges, that beam will be called as simply supported beam. If both end of the beam from here, you can see this end and this end is free, there is no support on one edge and another edge, this beam will be called as overhanging beam. If there are more than one or two spans, then the beam will be called as continuous beam. If there are two fixed support on both the ends, this is fixed support and this is fixed support on one end and another end of the beam, that beam will be called as fixed ended beam. If there is only one fixed support and one roller support, then that beam will be called as propped cantilever beam. What does span mean? Span is the length between two supports. You can see this is the span. From here to here, this is the span. This red line is the span between this support and this support. This span is called as this distance is called as span. The length between two supports, that is called as span. Okay. And these are the free body diagrams of different types of beam. This is cantilever, as I told you, simply supported, fixed, propped cantilever, overhanging, and continuous. Okay. And these are the different types of loadings which are used in structures. This is the column. You can see this is basically a column. Column is designed for which type of load? It is designed for, you will design column for point load. Point load is just applied in only one point. Means you have to in this direction, only one point of load. Beam is designed for uniformly distributed load. This is beam. Beam is designed for UDL. It will be applied on complete beam, on the throughout the complete length of the beam. So beam is designed for UDL load. And slab, this is a slab. Slab is designed for area load. Similarly, varying distributed load. This is varying distributed load. Varying distributed load is designed for this type of structure. You can see this is type of structure. This will be called as varying distributed load. Okay, and area load is the example of area load, that is storage of sandbags, making pyramid on a slab. That will be an example of area load. Moment, what does moment and couple means? If this is a beam and you have applied load on it, this is F, for example, the applied force, and this distance from fixed support to the application of load, this distance is, for example, is D, then what moment is called? Moment will be equals to F into D, F multiplied by D. What does the definition of moment is? Basically force into its perpendicular distance. Okay, and couple is also same as like a moment, but couple will have, for example, if this is a pin support at this center, if one force is applied over here, F1, and one force is applied over here, that is F2, this distance is also D and this distance is also D, same. Then these two forces will make a movement in this direction. It will make a movement and this direction. When the moment of this beam is generated in this direction because of these two forces, then we can say that these two forces are generating couple. Okay. From here we will study it in the next class. Do you have any question, dear students? This was just the old part, means you have studied this thing in your previous courses. It was just the revision of the previous courses. We are moving towards the designing. After studying this background of beam, then we will study different formulas, and after that we will design a beam on those formulas. Okay, so do you have any question in this complete lecture? Mr. Fario, Bruce Wayne, Charlie, Al, William, do you have any question? Any one of you?
Yeah, it's okay.
Did you understand today's lecture? Is there any suggestion to improve my lecture? Right now, how many students are present? 86 students. Please, dear students, after 2 minutes, join the meeting again so that I can mark you present. Okay, all 86 students should be present in this class, so I can mark you all of you present. Okay. Mr. Charlie, do you have any suggestion to improve my teaching quality? I guess he is disconnected. Yes, Mr. Charlie. Any suggestion?
No suggestion.
No suggestion. Mr. Bell, Bruce Wayne, Miss Grenda, Mr. Mark, do you have any suggestion to improve my teaching? Sui, Alex, Albert, Serial, September, Dean, Fecker, Seven, all these are the students who are active. Okay, this is the last minute of this section number 2. This call will be disconnected within few seconds. Please join it again. Okay, all of you, please join the meeting again so that I can mark your attendance. Well, dear students, before checking the attendance, I want to announce that when you all will be ready for the quiz. Mr. Bruce Wayne, we are in chapter number 4 of PCST. When you all will be ready for quiz, for tester.
Can you repeat it again?
Means when can I take a quiz? you remember, let me show you. In the first chapter, I have announced something. Quiz number one will be announced in week number 5, and it can be due in week number 8. Be ready for quiz number 1. I will maybe take it in week number 5 or maybe before week 5. We are, and this is week number 3, right? This is teaching week 3. So, will you all ready for the quiz in week number 5? Can we take it in week 5?
Okay.
Okay. So, be ready for the quiz in week 5. It may be in week 5. Or maybe, yes, I will take it in week 5 because week number 6 and week number 7 are off. There will be no class in week number 6 and 7. So that's why I want to take your quiz in week number 5. Okay. For both the courses, soil mechanics and foundation and principles of concrete structure design, both quizzes will be taken in week number 5. Okay. Remember that. Be ready for the quiz. And one more thing, I want to ask you one more question, that what type of paper you would like to give me, open book or closed book? Dear students, I'm asking you, Mr. Bell, Bruce Wayne, what type of paper you would like to give me? The exam paper should be open book or closed book? Are you understanding my point?
Yeah, we think open book is better. Yeah.
Open book is better. Mr.
Yeah.
Bell, what do you think? Open book or closed book exam?
Why?
I think open book is better. It's yeah.
Open book is better. Any other? To whom should I ask? Yes, Miss Grenda. Open book or closed book paper?
I think I need to open the book.
Well, you are solving my exam paper. Okay. Mr. Charlie, what do you think?
I prefer open book.
Okay, all of you are preferring open book, but remember that open book paper will be difficult, complex as compared to closed book paper. Okay, and marking will be also tough in open book paper, and it will be very loose marking in closed book. It depends on your choice. You have selected open book paper, so your quiz and your assignment and your exam paper, everything will be open book. Okay, it is done now. Let me take your attendance. Please be present. How many students are present now? 73 students. So I am taking your attendance right now.
So student, so teacher,
Yes.
what should we prepare for this quiz?
Sorry, I didn't get who is speaking.
Oh, teacher, I'm Fairel. I mean, What should we prepare for this quiz?
What you need to prepare for the quiz, obviously, and this week and in the next week I will finish chapter number 4. So you have to prepare. Let me show you. Please don't write. PCST quiz number 1 will be in week number 5. Okay, and you need to prepare chapter 01, 02, 03 and 04. Okay, all these things should be prepared. Remember this thing. Any other question?
Teacher,
Is it clear
could
now?
you mind sending to us those 50?
Wait, let me use my hands free. I cannot hear it clearly. Yes, please tell me, Mr. Fario.
Yes, teacher. Could you mind sending us those PPTs to our WeChat group?
Yes, I will. Even I have already sent these PPTs, but I will send it again because I have added your video lectures and these PPTs. So I will send these PPTs again in your WeChat group. Chapter number 1, 2, 3, 4. All these PPTs will be sent in your WeChat group. Please download it and study it. Clear? Okay, let me take your attendance now. The time is already finished, so let me mark your attendance. 76 students are present. I am marking your attendance. Please wait. Dear students, your attendance have been marked, so thank you for your presence. See you in the next class. Bye-bye.